point of view, psychogenic non-epileptic seizures or PNES are in the top differential diagnosis of status epilepticus. PNES was previously called pseudoepilepsy, which is not a good name because it implies that it is fake, like the pseudoscience of phrenology, popular in the 19th century, where the character traits were derived from the bumps and contours of the skull. PNES was also educated like a not-so-real disease more than 20 years ago when I was a medical student. I remember one of the registrars telling that two homeless people had visited her outpatient clinic. One of them had pseudoepilepsy and the companion told, "She has pseudoepilepsy, doctor, which is much worse than epilepsy because there's no anti-epileptic drug treatment for it." And we all laughed. It took me some years, maybe even a decade, to realize that PNES is a disease with a lot of impact, and what all patients with PNES have in common is that they experience a sudden change in behavior or consciousness without EEG abnormalities, so it's not an epileptic seizure. There's no other underlying disease, such as a cardiac disease, and, what is very important, there's no voluntary control. So it's not that the patient is faking the seizure, it happens at a subconscious level. And the treatment for PNES is mainly with cognitive behavioral therapy. So if you see this and have a medical background, you tend to think that this is not really a somatic, not a real disease. Let's be honest. But if you think of outcome measures, there's one very binary, unnegotiable outcome measure, and that's death. There's little inter-observer variability, and the relative risk of death in PNES is almost as high as the relative risk in patients with epilepsy, as published in Neurology 2020. So it should not be underestimated. PNES is psychogenic, which means that it arises from the mind, and I want to repeat something about the mind and learning that I mentioned in the intermezzo. I've shown this picture of an adult rat hippocampus, where you can see the axon and the dendritic spine, the synapse surrounded by glial cell, and if you learn something, the reaction of the postsynaptic neuron to the presynaptic stimulus changes. Plus, there's this mechanism of kindling that has been proven in animals, and there's some debate if it happens in humans and also if it happens in patients with epilepsy. And kindling means that there is a minor but permanent change in excitability within a pathway after repeating a stimulus, like Pavlov did with his dog. In PNES, there's the first stage where it develops. So there's some trauma or some trigger, some suboptimal or inadequate coping mechanism. Then this gets reinforced, maybe some kindling, and the PNES gets provoked, and then there's the last stage where there's prolongation of PNES, and 1/3 to 1/4 of patients become chronic. And it is a really diverse disease where the attacks can be either pseudosyncopes, they can be dystonic, or they can be the opposite, so hyperkinetic. So it's not a very uniform group of patients, but there are different pathways and different ways of presentation. I said there are no EEG abnormalities in the individual patients with PNES, but if you try to look at networks and pathways in patients with PNES, there was a study where they did resting state EEG in 18 patients, and again, keep in mind that it's a diverse group, so different type of PNES, both hyperkinetic, pseudosyncopes, and atonic. And they found that there was weakened functional connectivity in patients with PNES at the level of the basal ganglia. And also from a pathological and anatomical point of view, this makes sense because if you think of diseases like Huntington and alien hand syndrome, they also have these motor symptoms. And they also arise from the basal ganglia. So this hypothesis is easy to accept. There were not many studies in PNES patient capturing the seizures. There was one with a patient with atonic PNES, which is good because then you do not move. And he or she was participating in an fMRI study and experienced a psychogenic seizure. And what they found was that during the seizure compared to resting state, there was activation in the left temporal and temporal-occipital region and deactivation in the right parietal region in the lingual gyrus, so that's also temporal-occipital, and in the cerebellar lobules. And these are networks involved in emotional processing, dissociation, and self-perception. So in PNES, there might not be abnormalities on the structural MRI, but there's definitely something abnormal at the level of the networks and functional connectivity. And having said that, I want to go back to the patients with epilepsy and talk about another important switch box, and that's the thalamus, and talk about deep brain stimulation in patients with epilepsy in the next Brain Bit by Bit. Thanks for